you are welcome. Today we shall be doing a recap of this week topics. All right, so basically just the important ones that you shall be reminded of. And then I hope to see how we will do our activity on a Kahoot today. I hope it doesn't get stuck somehow. Okay, but everything is prepared for the Kahoot. All right, so let's get going. So from a few days ago, we looked at what acid bases and the pH value. And then we said an acid is a substance with a pH between 0 and 7. We also said that a base is a substance with a pH between 7 and 14. And then we then said that pH is a measure of how acidic or basic a substance is. And then we also said pH is a number between 0 and 14. And then we also said that acids taste sour and feel rough, and bases taste bitter and feel slippery. We also said that both the acids and bases are very dangerous. They are dangerous because they are very, very corrosive, and they can damage your skin, or if I may say, corrode or wear away your skin or any other material that it comes in contact with. All right. Then we then looked at what the relationship between the reaction and then the pH, and then we learned that acid and bases will react together to give us a neutralization process. All right. We then said a neutralization reaction involves an acid and a base or alkali. And remember, an alkali is a base, but it's a soluble base. Then we said when a base is added to an acid, the pH increases. And then when an acid is added to a base, the pH decreases. So in order to form a neutral solution, the correct quantity and strength of an acid and base must be mixed together. The products of a neutralization reaction are a salt and water. So what we need to know is that when we react an acid and a base, which are going to be the reactants, subsequently what we are going to get, a salt and the water are going to be the product. Sodium hydroxide is a base, and the pH of sodium hydroxide is about 11. All right. Now, guys, if I am very fast, you just let me know. And if my voice too, you are not hearing me, you just let me know so that I can amplify or just adjust. In a neutralization reaction, an acid and a base are the reactants. So I just said that in a neutralization reaction, the acid and the base are reactants, and the salt and the water are the products. Okay. In a neutralization reaction, a salt and water are products. It's repeating here to emphasize. If we add a base to an acid, the pH, the pH of the resultant solution will increase. The original solution will become more neutral. If we add an acid to a base, the pH of the resultant solution will decrease. That means that the original solution will become more neutral. So let's look at an example, a typical example of what a neutralization reaction. So the HCl, which is hydrochloric acid, react with the base, which is sodium hydroxide, and then giving us what? Sodium chloride plus water. Now, so if you look at this, the acid and the base, you will find out that the acid has got a negative and a positive part. So the one on your right, if you look at HCl or hydrochloric acid, the one on your left is always a positive, and the one on the left is always negative. So we have got a positive component and then negative component. Also, if we look at NaOH, sodium hydroxide, Na is the positive, and OH is the negative. All right. So the negative and then the positive of the acid will react, and the positive of the acid and the negative of the base will react, so that we will get this. All right. Now, the other thing we have to check after this, you have done this, you have to check to see whether your equation is balanced. So how do we balance an equation? We have to make sure that the number of moles or the number of atoms on the left-hand side should be equal to the same number of atoms on the left-hand side. So how do we do that? We have got, so let's look at hydrogen. Hydrogen, we have got one hydrogen on the part of the HCl and another one on the part of what? The sodium hydroxide. So H plus H will give us 2. So what do we have on the right-hand side? We also have what? 2. Okay, that is sorted for hydrogen. Then we check again. Chlorine on the left is 1, chlorine on the right is 1. So that is fine, it's balanced. Sodium on the right is 1, sodium on the left is also 1. Then that is fine. Oxygen on the left is 1, oxygen on the right is also 1. So meaning everything what is sorted, so it's balanced. So when you are trying to balance an equation, you have to check. You have to check both sides to see whether everything is fine. All right. Then we looked at various forms of neutralization reaction. You remember we said an acid can react with a metal oxide, and with a non-metal oxide, and with what? A metal carbonate. Okay, so let's look at what? The reaction between a metal oxide and then what? An acid. Okay, sorry. Guys, sorry about that. A metal oxide is a compound formed when a metal reacts with what? Oxygen. So take note. What is a metal oxide? A metal oxide is a compound formed when a metal what? Reacts with oxygen. Okay. So when metal oxide reacts with an acid, then the product that is formed or the product formed are what? A salt and a water. A salt is a compound made up of what? A metal and a non-metal. So let's look at the general reaction. The general reaction is what? An acid plus a metal oxide giving us what? Salt and water. I hope that is fine. When a metal oxide reacts with an acid, the reactants are the metal oxide and then the metal. So you take note. So when a metal oxide reacts with an acid, the reactants are the what? Metal oxide and then the metal. Okay, so a metal oxide is formed when a metal reacts with oxygen, just for emphasis. When a metal oxide reacts with an acid, the products are a salt and water. A salt is a compound made up of what? A metal and a non-metal. The type of salt formed will depend on the specific acid and the metal oxide used in the reaction. So the general equation for the reaction of a metal oxide with an acid is given. So there are two here, metal oxide, the general equation, and non-metal oxide, also the general equation. So let's see how metal oxide is formed. A metal reacts with oxygen to give you a metal oxide. And when then this one reacts with water, you get what? A basic solution. Then when a non-metal reacts with oxygen, then we get what? A non-metal oxide. And remember, a non-metal oxide reacts with water to give you what? Acidic. So this table summarizes a lot. So it's basically saying metal oxides are basic. Why are they basic? They dissolve in water. And when you were to take or you were to calculate or measure the pH, you will find out that the pH will be what? Greater than 7. Okay, then examples of what? Metal oxides, you have both lithium oxide, sodium oxide, and magnesium oxide, and calcium oxide. Okay, guys, I want you to, if you are following, I want you to give me an example of a metal oxide, the formula. So let's say potassium reacting with oxygen. Can I get the answers to see whether you are following, guys? What is the formula for a metal like potassium reacting with oxygen? And then we are going to get what? A potassium oxide. So how will the formula look like? Okay, let's see. How will the formula look like? Yes, that is in weight. Write it in using formulas, symbols too. Tando, that's very good of you. You have given me the answer in word formula. I want you to give it to me in chemical formula. So what will the formula look like? Okay, fantastic. Yes. Amraha, you have done that. All right. I'm waiting for the rest to see whether you are following the lesson. Let's be fast, guys. Send them in, send them in, send them in, send them in. Okay, let me see who. Yeah, yeah. Okay, it's still Tando. It's still Tando. I'm left with Adam. I'm left with other six. Yes. Clooney, send in your answer. Mark, send your answer. Reading, Mitch, send in your answer. Send your answer so that I see that you are following. Okay. Waiting, 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 waiting. All right. I'm waiting. I'm waiting. I'm waiting. Yes. All right. I'm waiting. I'm waiting for your answers. I'm waiting for your answers before we can proceed. I just need one besides Amraha and Tando. I just need one or two. So if you didn't listen, I said potassium, which is a metal, reacts with oxygen to give us what? A metal oxide. So the reaction is going to be potassium plus oxygen giving us potassium oxide. And I want you to write the symbol for potassium oxide for me. Basically, that's what I'm saying. All right. Yeah. Cloning, write the formula. Write the formula. That is a word, a word. You are giving me the word, write the formula. Write the formula, write the formula, write the formula, cloning. Write the formula, write the formula, write the formula, write the formula, but not in word. Okay. I'm waiting, I'm waiting, I'm waiting, I'm waiting, I'm waiting, I'm waiting. I'm waiting, I'm waiting, I'm waiting. Okay. Max, can you still hear? I think everybody can hear me, but I hope you can hear me now. Okay. All right. So let's proceed. Then we have got non-metal oxides. So carbon reacts with oxygen to give us this. Sulfur reacts with oxygen to give us sulfur oxide or sulfur dioxide. And then we have nitrogen reacts with oxygen to give us nitrogen dioxide. And then phosphorus reacts with oxygen to give us what? Phosphorus pentaoxide. Okay. All right. Okay. Okay. Then we also heard from the previous lesson, we also studied what? Reactions of acid with metals. And then the typical example that we looked at was what? HCl plus magnesium. So let's see how this one is also done. All right. When any acids react with a metal, the products formed are a salt and hydrogen gas. The type of salt formed will depend on the specific acid and metal used in that reaction. So the general equation is acid plus metal salt giving us what? Hydrogen gas. So hydrogen gas. So now let's look at the word equation. A word equation is hydrochloric acid reacting with magnesium to give us what? Uh, Magnesium chloride and hydrogen gas. So let's look at the balance equation here. So guys, take note how we balance these things. So we have got HCl reacting with what? Magnesium. And then the magnesium. So this is what is called a replacement or displacement. Let me say replaces. So if you look at HCl and then the product side, you will see that the magnesium has taken the place of what? Hydrogen. So for us to get what? Magnesium chloride plus hydrogen. So how do we balance it? So if you check, just ignore for once the two in front of hydrogen chloride or the hydrochloric acid. Now, if you ignore it, we are going to have what? HCl plus magnesium giving us magnesium chloride and hydrogen gas. So you see, hydrogen gas is going to be 2. And then that side is going to be 1. So if on the right hand side is 2 and on the left is 1, so if we want to balance, we have to put 2 here. When we put 2 here, then we will see that it's fine, it's balanced for hydrogen. So, but when you write the 2 is affecting the whole HCl, meaning it's multiplying. So when we write 2 here, you see that when we write the 2 here, you see Cl is also 2, so which is balanced here. Now let's look at magnesium. Magnesium is fine, and then what is fine? So we have got HCl reacting with this to get magnesium chloride. Okay. All right. Now let's look at reaction of acid with bases. Reaction with acid and bases. Okay. So let's go on. So reactions of acid with bases. So, and then we are going to look at what metal carbonate. Metal carbonate are bases. When any acid reacts with a metal carbonate, the product form are a salt, carbon dioxide, and water. The type of salt form will depend on the specific acid and metal carbonate used in that reaction. The general equation is always what? An acid plus a carbonate, metal carbonate, giving us what? An acid plus a metal will give us what? A carbonate, which is salt plus carbon dioxide and water. So let's look at the examples here. We have a word equation. HCl plus calcium carbonate will give us what? Calcium chloride plus carbon dioxide plus water. So this is the equation. So HCl plus calcium carbonate will give me what? Calcium chloride, water, and carbon dioxide. So take note, an acid reacting with what? Metal carbonate will give me calcium chloride, carbon dioxide, and water. Now, before we go, I just want to go back to the previous slide. I want you to do something for me. Okay. Now we looked at this equation, the balance equation now. So guys, I want you to do something for me. Write HCl reacting with what? Zinc. What are you going to get? What will be the product? Can you kindly send me your answers? Zinc reacting with HCl. What are you going to get? So you guys just send in your answers so that I know that you are following, guys. So that I know that you are following. Okay. All right. Let's go on. HCl reacting with zinc, what are you going to get? All right, guys, did you hear me? Yes. All right, send me your answers. Send me your answers. Send me your answers. Send me your answers. Okay. Let me see that. All right. I said, okay, if you can see the slide here, I said we got this equation is telling us that HCl is reacting with magnesium, and we got what? Magnesium chloride plus what? Hydrogen gas. Then I'm saying let's react with HCl plus zinc. What are we going to get? Yeah, that's what I'm saying. I hope you heard me right. Okay, HCl plus zinc. What will be the product? What will be the product? The product will be zinc chloride. Yes, but what is the formula? How is the formula down? How is the nature of the formula? Write it down for me. That's what I'm saying. Okay. All right. Did you get me right? Okay. All right. Send it in, then we go. Send it in, then we go. Yes. I hope you heard me right. Okay. Are you guys still typing? Yeah, perfect, perfect. Amraha, can you now balance it for us? Just try. You can balance it. Just look at the sample there. All right. Tando, can you see what Amraha did? Yes. Amraha, try to balance it for me. Just look at the balance equation for HCl and then magnesium chloride. Okay. Yeah, Tando, you are correct. That's what we're going to get. But Amraha gave the full equation for zinc plus HCl. Okay. All right. Now let's proceed. Let's proceed. Let's proceed. Let's proceed. Let's proceed. Okay. Let's proceed. All right. So we were talking. I already spoke about this one. Metal carbonates are bases. So when they also react with what an acid, you are going to get what salt, carbon dioxide, and water. Uh, it's not balanced. If you see your hydrogen on the right hand side is 2, but on the left is 1. Cl on the right hand side is 2, but on the left is 1. So you need to write 2 in front of HCl. Can you see that, Amraha? Can you see that? So when you write the 2 in front of HCl, then the equation is balanced. Yeah, very good. So now it's balanced, but before it was not balanced. So if you add the 2 there, then everything will be balanced. Okay, I I I I hope you are fine there. Okay, so the general equation for metal carbonates reacting will be what an acid plus the carbonate will give you what calcium chloride, the carbonate salt, the carbon dioxide, and water. So we have got what? A balanced equation down for what? Metal carbonate reacting. Yeah, perfect. So it will be like this. Very, very good. Amraha, that's perfect. That's perfect. You have done well. Yeah, yeah, yeah. That's correct. Perfectly correct. Then we then say that the equation is balanced. And the mole ratio between what? Zinc to H hydrochloric acid will be what? 1:2. Fantastic. Okay. Now let's proceed to the next. All right. And then we also looked at what? This one is just an addition to the reaction between what? Acid with metals, but more specifically metal carbonate. So we said when an acid reacts with a metal carbonate, the products formed are what? A salt, carbon dioxide, and then water. The type of salt form will always depend on the specific acid and the metal carbonate used in that reaction. Yeah, so this is what we get. So when an acid reacts with a metal carbonate, we're gonna get salt plus carbon dioxide and water. All right. Okay. So more information here. So if a metal carbonate reacts and then an example of a metal carbonate is going to be what? Calcium carbonate, which is just a chalk. All right. So we said a carbonate is formed when a carbon atom and 3 oxygen atoms bond together. So an alkali is a base that can dissolve in water. Metal carbonates are bases. So why are they bases? They have a pH greater than what? 7. The product of an acid metal carbonate are salt, water, and carbon dioxide, as we have seen in the previous lesson. Okay, so Let's look at the word equation for the general reaction. We have already seen that. A metal carbonate reacting with the acid to give us the salt and water. That's fantastic. Okay, so we have already, yeah, let's look at the implication here or application. So we said between carbonate uh, and then an acid, carbon dioxide gas is released. So what does that mean? So sometimes if you want to try to neutralize something, uh, okay, let's read before I say what I want to say. Carbon dioxide gas is a product of the reaction between a metal carbonate and acid. Lime water is solution of what calcium hydroxide and water. So I was saying if you have an acid and then you have what calcium hydroxide, then you can balance or neutralize it. Okay. And we remember there is this tablet, milk of magnesia. Sometimes when you have got some stomach upset, they give you milk of magnesia so that you can, as a prescription, so that you can take it in. So when you take it in, it's sort of mostly it's for stomach upset or stomach disturbance. Okay, calcium carbonate is a base, HCl is a base, and carbon dioxide turns clear lime water milky. So if you want to test the presence of carbon dioxide, if you have a gas and you want to test whether it's carbon dioxide, if it if it turns lime water milky, then perfect. It tells you that that gas is what an acid. That gas is what carbon dioxide rider. Okay, so let's go on. Oh, yep. So this is just a summary using a what a mind map or a flow diagram, if or concept map. So we have looked at what reactions of acids and bases. All right. So we have got reactions of acids and bases are called what neutralization reaction. And at the end of the day, we can get the final pH. The final pH will tell us whether the solution is basic or acidic. Now, so for example, hydrochloric acid, non-metal oxides, and sulfuric, when they add, then when you get non-metal oxide, they react with water. An example is carbon dioxide, sulfur dioxide. When they release, where do we get them? We get them from burning fuels. So they can lead to the formation of acid rain if they dissolve in water. Then when we come to bases, we can have a metal oxide, we can have a metal hydroxide, and we have what? A metal carbonate. On my far right, a metal oxide is formed when metal reacts with oxygen. Then this one reacts with water to form salt and water. Now, when we look at metal oxide, a typical example is what? Magnesium oxide. Then we look at metal hydroxide. This one is metal plus water. We get it from metal plus water. It reacts with acid to give us what? Salt and water. And then we also have what? Sodium hydroxide. Okay. So we also looked at what? Metal carbonates. They react with what? Um, water to form carbon dioxide and water. Okay. All right. Then we also look at what? Calcium carbonate is a limestone and has what? Many applications and is used in buildings and in what? Agriculture. So, guys, I quickly want to try to do something here. I want us to log in into Kahoot, but I want to just do something here so that to see. All right. So let me just try to switch. So just bear with me for now. So guys, I'm just trying to switch to